Hello, everybody, and thank you for joining us for our fourth webinar, Level Up with Fusion in Secondary Education. This one is called Get Started with CNC. My name is Jason Erdrich, and I am a STEM and technology and engineering educator on the East Coast of the United States, and I am teamed up with the Autodesk and Tinkercad and Fusion teams to provide training resources and webinars like this for you, so that way we can engage your students with really exciting projects. And as always, I'm joined by my co-host, Randy. If you want to say hi.
Hi, I'm Randy. I'm on the Autodesk team. I work on primarily Tinkercad and Instructables, and I'm excited to be here tonight to also talk about Fusion, another thing I sometimes touch on.
Yeah, which is super great. And listen, behind the scenes, I'm not sure if you can see who's with me here with their webcams, but we have always some Tinkercad and Autodesk team members joining us every time we do these webinars and helping us prepare for them. So I have Nicole who's with us here. She's going to be interacting with you via the chat, and we might have some more folks pop in later on for the Q&A. So just a big thank you and shout out to the whole Tinkercad and Autodesk team for helping me as we try to plan and implement these webinars. Now, super excited that you're here for today's webinar, which is called Level Up with Fusion in Secondary Education. And tonight's all about getting started with CNC. But I'm also really excited that we are going to be tweaking our webinar schedule a little bit. And we mentioned that this is coming. We said that we wanted to hear your feedback, see what you were looking for, and be able to provide as much support as we can across all of the engineering, design, CAD, CAM worlds in education. So what we're doing is we are launching a brand new webinar series called the Design and Make series. And this is actually going to take over from this Fusion series. So we're going to transition from the individual Tinkercad series that we ran in 2023 at the start of the year and the individual Fusion series that we've run now for 4 webinars. And we're kind of making more of a widespread culminating series called Design and Make. And as I think many of you know, Autodesk has a ton of different products, resources, programs, ways that students can engage with designing, creation, engineering, all these amazing things in their classroom. And we really want to show you how wide and broad that is, and also support teachers coming from so many different areas. So starting on February 15th, in 2 weeks, same time as we're meeting now, we are going to be meeting through this new webinar series, and we'll still be looking at Fusion. We'll still be talking about Tinkercad. We've posted a number of topics and things, and we'll post those a couple weeks in advance as we can, so you can kind of see what's coming up. And if you are registered for the Tinkercad, the Teaching with Tinkercad series from the beginning of the year, you do not need to re-register. But if you did only register for this Fusion one and you'd like to attend this Design and Make one, you do need to register. We did just drop the link for that in the chat. You can also find it in the slideshow, which will be shared with you later on. And also you can find it on the Tinkercad blog. So we're super excited to be offering this series to, again, promote a wider range of topics and things across everything that Autodesk does to help students design and make everything with Autodesk products. So really cool. And I'm also excited to announce that the first topic on February 15th in 2 weeks is going to be learning electronics and coding with Tinkercad Circuit. So Tinkercad has a really powerful circuit simulator. We learned about Tinkercad 3D design in the previous series, as well as code blocks. We haven't talked about circuits yet, but we know a lot of people have been asking for it. So how can you simulate electronic circuits? How can you program microcontrollers? That is what next topic is going to be all about. So again, we hope we see you there, and we're super excited we're going to be launching this new series that kind of combines everything that we want to do. So really, really cool. And of course, thanks for your continued support so we can keep running series like these. Now, that being said, we'd love for you to introduce yourself a bit more and also learn a little bit more about your program. So we have a poll that just popped up, and we're saying, what is your size classroom, but really, how many students do you teach? So if you teach one class, what would that class be? If you have multiple classes, if you teach across semesters, we're just trying to gauge exactly how many students you might be impacting with the type of content we're trying to cover tonight. And again, these things not only help us learn a little bit more about your own situation and what we can do to support, but also allows us to create things like the Design and Make series to be able to provide more support to you. So I see, we'll give you another couple seconds here to answer, but I see that we have a lot of folks in the what I would say larger size, right? So a lot of you are teaching 90 to 120 or even more than 120 students a year, which is really cool. Some of us have maybe smaller groups and things like that, and that makes perfect sense. I saw that we're coming from all over the different STEM, robotics, engineering fields. So that's really cool. Thank you so much for answering that. But it looks as a whole, we have some larger groups of students, and of course, that adds its own sets of challenges. So hopefully we can talk about how you can support that and how you can engage with all your students and allow them to find success. So thank you for that. That's really cool. It's awesome to see that we have such a diverse group in front of us. So again, thank you for that. Now let's talk about how to participate in these webinars if you've never attended one before. The chat is super active, right? So we'll be dropping links in the chat consistently. You are welcome to drop questions and things in the chat. Anything I mention, usually the Tinkercad team behind the scenes works really hard to make something magically appear as a reference. But the best place to also participate is using the Q&A feature. So the Q&A button on your Zoom toolbar will allow you to ask a question. And the benefit about the questions is that they won't go away until we answer them. So sometimes the chat scrolls really fast. We kind of lose some of the questions and things that are asked. So please take advantage of the Q&A, and then everyone can also go back and see the questions that have been answered later on. I also want to point out that this webinar is being recorded. So we're going to post this webinar to our YouTube channel and share that link out with you tomorrow. The slides are also going to be shared. So every visual you see, you'll see that some things are linked in the slides. We're going to share the slides with you tomorrow as well. And then at the end of this, we'll have a Q&A session with myself, the other Autodesk team members that have joined me here, so you can ask some questions directly about the content that we covered. So stay tuned for all of that. Now, in case you don't know, and in case this is your first webinar joining, and especially because this is going to be the last one that's part of the Level Up with Fusion series before we transition to our Design and Make Anything series, what is Fusion 360? Well, it's one of Autodesk's program, and I think it's arguably one of the most diverse programs in what you can do. It allows you to make 3D designs. It allows you to manufacture things, which is where we're going to be spending most of our time tonight. But you can also make electronic circuit boards. You can simulate your models, like will they break? How would they handle stress and strain and loads? You can collaborate among teams and peers, and students can share their designs with each other, which is great. You can use generative design to help AI and these different design tools help you create designs, which is really, really a hot topic in industry right now that you can take advantage of. And as we learned in our last webinar, you can even render and animate and create 3D graphics that look hyper realistic. So it's a really diverse program that allows students to do what is happening all across industry, whether it's an animator, a creator, a model maker, whatever it is, and they can bring those resources, or you can bring those resources into the classroom to allow them to engage with all of this in just one program. So it really gives us a lot of options. And what that means is your students can push their ideas into the real world, right? So with all of these different tools at their disposal, their designs can really come to life, from circuit boards to 3D modeling, 3D printing, CNC milling, animations and graphics and things like that. It's a very diverse way for students to be creating. And I find personally as an educator that it really engages with a wide range of students, which is really, really cool. Now, Fusion is accessible in two different ways. So you can access it via a web-based app on pretty much any device. So you can load it in the web browser, kind of like you would do with Tinkercad if you're coming from the Tinkercad crew. Or you can also use it offline using a desktop app for Windows or Mac computers, which is really nice. So super accessible for students in whatever your classroom environment might look like. To use Fusion, it is completely free for students and educators, but to gain access to it, you do need to create a free Autodesk account. Depending on where you are in the world, the age requirement for students might be different. So that's usually 13 years old in the US, and that varies a bit based on your region. But creating accounts are completely free, and again, it gives all the premium and all the paid for features to you for free, so your students can engage with the professional features that real designers and pros might be using in industry right in the classroom. There's also something called Fusion Teams, and this is kind of sort of like making a class in Tinkercad where you can create some type of team, invite your students to it, and that's where they might share their work. They might submit work to, something, a project that you could create. This is where students can share work between group members and allows them to collaborate with their designs. So this is a really great way that students and you can interact. You can see their designs, you can provide feedback and things like that, which is super cool as you look at their projects. And I also just want to point out, especially if you're new to Fusion, that Fusion is infinitely customizable. So you can change all the menus, all the ways you navigate. If you look at my Fusion screen later on, when I start projecting and sharing my screen, you might notice that my toolbar is different than yours. That's just because I've customized my tools and I put things where I want them to be, and I'll show you how to do that when we dive in. But if you're coming from Tinkercad, which I know so many educators and students are, I recommend that you actually go into the menu for Fusion, and you can even adjust the navigation tools like the mouse, the wheel, how you scroll, how you zoom, how you select things. You can make it mimic Tinkercad. So that way, students that come from Tinkercad, they're used to navigating and things like that. They can make Fusion feel more comfortable for them, and that's definitely a more intuitive and easy way to learn. And even me as an educator, the first day of introducing Fusion, what we might do is actually set up our toolbar, the tools that I know they might be using. We adjust things so that it suits what we're doing in our classes and then allow students to engage more successfully. And the link for doing some of these things was just dropped in the chat for you to take a look at. So let's cover the basics. And this is now specifically getting into tonight's topic about getting started with CNC. And there are so many different things you can do. And this is such a wide topic that realistically in our time tonight, we can only start to scratch the surface. But my goal is for you to kind of get a general understanding of what it is, the types of projects you might be doing with your students, the types of resources you might have or need, and then also, of course, how to use Fusion 360 to do these things, right? So the first is let's cover some key terms. CAD versus CAM. CAD stands for computer aided design, and that's software that's focusing on the design of the product or the part. What does it look like? How does it work? Something like that. CAM stands for computer aided manufacturing, and that stands for focusing on manufacturing the product, how the part is actually made, right? Now, there are programs that are exclusively CAD. So for example, you can see that I have some little icons here. So Tinkercad is a CAD program where you design things, and Autodesk Inventor is another program in our suite, which is where you would design things. And then there are programs that are CAM, which is where you would take your design and prepare it for manufacturing. And Fusion, as you can see, actually does both, right? So we've covered in previous webinars, and we do have a link to how to get to all of our webinars and things like that. On how to design in Fusion, right? We covered CAD and designing and things like that. And tonight we're really focusing on the CAM piece. How do you take your designs? How do you bring them to life? And there are some programs out there that are exclusively CAM or whatever it might be, but one of Fusion's biggest benefits is that it's a kind of a one-stop shop where your students can do the entire design and production process in a single program. Now you might be thinking, okay, why do we need CAM, right? Well, let's imagine that I have this design in CAD that I designed. This is a little desk organizer or something for elementary school desks to organize your pencils and things, and I want to 3D print them, right? I can't just take my design file, my STL file or my 3D part file, and send it directly to my 3D printers. That just doesn't work. And the reason being that my 3D printer needs to know what is the quality, right? How quickly do I want to print this? What is the layer height, for example? How smooth do I want these parts to be? What material am I going to use? What plastic is this going to be in? So what temperatures does it have to be at? I need to set all of those settings, and that is exactly what's done in CAM. So what I first do is I design something in CAD. I then drop it into CAM, and this is all happening in Fusion. So this is all happening in the same place. And we did talk about this in a previous webinar called 3D Print Better, which you can go back and see if you are interested in learning more about the 3D printing world. And then in the CAM piece, that's where I say I'm using this plastic, I'm doing this quality, and then I send that file, which is usually a G-code file or a coded file, to my machine. And in this case, we're talking specifically about 3D printing, but the concept is pretty universal for any type of computer-based manufacturing, which we're going to be talking a lot about tonight as we talk more about CNCs. So that's where CAM comes into play. And there's a lot of different types of manufacturing processes, right? So 3D printers fall into the additive process group, right? Where we are adding material. You start with nothing, and we're either melting a roll of filament, if it's like a fused filament fabrication method, or there's other types of 3D printers that use the liquid resin, which actually uses a laser to harden the resin, whatever it might be. We're adding material to create a model. Another type of manufacturing process, and one that is more commonly associated with CNC production, is subtractive manufacturing, where you put in a block of material and then some type of cutting process, drilling, cutting, whatever it might be, will actually remove material. It machines it away and then creates your final parts. You can get very similar parts, arguably, depending on your machines, but the way that the parts are made are kind of inverse. They're completely different. And then there's a third type of process group, which is through formative, where you might have a mold, and then you pour hot plastic into it, and then you would remove the mold, and then you'd have your part. And that is how most of our products that we buy are created. But additive and subtractive are not only used in industry, they're also still widely used in the prototyping method. So for example, if I was going to mass produce something, I might use a formative method, but before I mass produce it and make my mold, I'm probably using additive or subtractive to make prototypes. And again, I do want to point out that there are plenty of products that are actually made using purely additive and subtractive as well as formative. Now I'm bringing this up to again point out the diversity of Fusion's program. On the previous slide, I showed you that we can of course use Fusion to prepare models for 3D printing through an additive method, but we can also use Fusion to prepare models through a subtractive method, where I can bring a model in and actually carve it away, plan this out, and we'll be spending a lot of time talking about this tonight. But what's really cool is you can even talk about the formative method. So you might make a part like this in Fusion and then use the simulation window to determine what that would look like through a formative mold making method. So what you're looking at is a textured map for just showing me where might my part warp, where might my part fail, right? If I was going to make this in like an injection molding process and mass produce these out of plastic, where might I have issues in my design? Fusion will analyze and point all that out to you automatically in the simulation feature. So one program that lets you work with all three of these typical manufacturing process groups. And while we're not talking about all three tonight, it's important to know that they do kind of connect and relate. What we are talking about is CNC. CNC stands for Computer Numerical Control, and essentially it's a machine that runs based on, or its movements are controlled by a computer, some type of computer process, usually some type of coded file, and that coded file is typically called G-code, and that's the language it's written in. And yes, way back in the day, people used to write this by hand, and you still can if you want to give it a go. But CAM software will generate G-code for you based on the parameters you set. And CNC is really broad. However, it typically refers to these types of machines. So when somebody says I'm working with a CNC, they're usually talking about either a mill or a router, which uses kind of like a drilling process, or sort of like a drill bit spindle like thing. And that will be used to carve away material. And I'll be showing you visuals in a moment. They might be referring to a lathe, which is a turning center, where you might have something that's rotating on a continuous axis, and then a blade is sort of carving it away to make very symmetrical and cylindrical type designs. Or there might be cutting machines like a laser cutter, a water jet cutter, or a plasma cutter, right? These are usually the most common CNCs, but I want to make it super clear there are many more. 3D printers are technically classified as CNC machines, not that we usually refer to them as them, but they are. They run on G-code and computer numeric control, just like these machines. And there's also a bunch of other ones that are used in industry like EDM machines and many other types of processes, but these are usually the most common when we say the word CNC. Now, the first important tip before we dive into the design is to get to know the capabilities of your machine that you have. And as a designer, and as you're teaching your students to design to be successful with CNC production, and right now I'm talking mostly about subtractive manufacturing with a milling or lathe or turning process, whatever it might be, we need to know what our machine can do, right? So I might have this design. It's a very simple block with a little J on top, like an extruded J. And before I go to manufacture this, I need to consider the size of this model. I need to consider the detail or the resolution, like how sharp are my corners, how fine detail am I trying to create, and what material. Do I want to make this out of wood? Do I want to make this out of metal, right? Does my machine have the capability to do that, right? If I have a very small CNC mill, I know I can't put in a large sheet of plywood. And if my mill doesn't have, maybe coolant or a spindle that can handle it, I might not be able to make this out of aluminum, right? So knowing those things and designing around those constraints about what your machine can do is an important thing to understand as you want to become a more successful designer before we dive into the CAM process. But let's say that I set all these things correctly and I send this model to, a typical CNC mill that can machine a lot of different materials. This in particular is wood, and it would use, again, a drilling process to drill away or cut away this block of wood to then give me my finished product, right? So it carves away, and you can see that there's some sawdust in the background because it's shaving the material away to give me this finished product as I go. But your designs can vary, and what you need from your machines might vary as well. So let's say that I have this far more complex model, right? I still want to consider size, and this in particular is much smaller than the J I just showed you. So I don't need a very large machine to do this. But as we can see, the resolution, the detail is far higher. There's a lot of detail in this model between the ears, the eyes, all the little details on, the necklace and the hat and things. And also the materials might be a consideration. If I want to get this fine detail out of a really hard material like metal, like making this out of solid aluminum or brass, I would need a machine that has enough rigidity to get that detail out of a harder material, where maybe a more entry-level machine could do something at this detail out of a softer material like wood or even epoxy or wax like this. And now, because of this geometric challenge, I would also need a machine that can machine in a couple different axes. So what you're seeing here is not a lathe. This is called a fourth axis machine. So it's actually rotating my block of material, this white block of material, which is a plastic, and it's then machining it away to actually create our model. So it's able to rotate and drill and create to give us that high detail of our part as we're machining, right? But if I didn't have a machine with a 4th axis or 5-axis configuration, something like this from a subtractive perspective would probably not be possible, at least without a lot of different steps. And I keep mentioning axes and things like this. So what does that actually look like? I have this nice little graphic of typical configurations. There are other ones that I'm not showing you, but these are kind of the most common. Let's say that you have a very simple CNC machine, like a laser cutter or a vinyl cutter that makes like decals and things like that. That is usually a 2-axis machine. The head of the laser can move side to side, which is usually X, and backwards and forwards, which is usually Y, and it moves around to cut out our stuff, right? A 3D printer and most CNC machines that you would get for especially the hobby or entry level are 3-axis machines, right? So they can move side to side and backwards and forwards just like a laser can, but they also move up and down, right? And that's what gives us our Z dimension. And now you might be thinking, okay, wait a minute, if I have a 3D design, like this Nefertiti logo or design I just showed you previously, don't I just need 3 axes to make 3D parts? Well, when we have CNC parts and we're drilling and we're cutting and we're machining, we might need to rotate our part to get to different angles depending on the types of designs, right? So what a 4th axis machine does, and what I showed you previously with the Nefertiti, is in addition to being able to move side to side, backwards, and also up and down, it can rotate the material to really get from it from almost any angle. And the next step above that, that would even be more precise and give us even more, I don't want to say limitless, but far more flexibility, would be a 5-axis machine, which would be able to rotate the model maybe this way around and then also this way and around, right? Or it actually might just rotate the head, like the cutting head could actually move and rotate, almost as if the drilling head on a mill is on a robotic arm and that can rotate around. So again, there are a lot of different types of CNC machines. And if you're trying to choose one, you really need to define what is the type of detail that you expect, what is the type of materials that you want to work with, because CNC machines can typically work with a much wider range of materials than 3D printing, from plastics and soft woods and carbon fibers and metal, but it all depends on what your machine is equipped with. From Fusion's perspective, you can design and use pretty much any of these options. You just need to know what you have available as you dive in. And this is kind of what I'm talking about here. So here's a cube that's rather detailed, and you can see that the CNC on the left-hand side here, and this is a 5-axis machine, is rotating the cube around so it can really machine all of these pockets, all of these holes from each face. Now, could you make something like this without a 5-axis machine? The answer is yes. So for example, if I had a typical 3-axis machine, I might put in my block of aluminum, I might machine the top of the block. Then I physically remove the block, rotate it, and then do the next side. And then remove the block, rotate it, and do the next side. And I might rotate this block 5 times or 6 times if I want to do all the sides, where a 5-axis machine, in theory, would be able to rotate all the way around autonomously, right? So from a production standpoint, if I want to mass produce these, I don't want to have to be able to babysit the machine and rotate the part around every so often to machine the sides. I'd want my machine to do as much as possible. But from a hobby and an education side, really, there are a lot of different things you can do. It's just kind of getting to learn your machines a little bit before you dive in. So this is sort of just a background on CNC machines, because I'm about to show you a lot of features for production in Fusion. And if we didn't cover some of these definitions, maybe it wouldn't click necessarily. So hopefully that was helpful for you. And again, I want to remind you that these slides are going to be shared if you want to go back and dial in. I also, before I project my screen to Fusion, I just want to point out that everything I mentioned live, so I'm about to demo a bunch of things to you, I have a slide for. So when we share these slides with, you can kind of click through, and there are a lot of notes and things, which I won't be showing on the screen, but you'll be able to kind of go back and see all of these different resources after we share this presentation with you. So I did just flip my screen, and can somebody in my Autodesk team give me a thumbs up? Can we see Fusion? Okay, is that all right? I'm doing something slightly different. Fantastic. Thank you. So I am in Fusion 360. And I have a part, right? So this is a part that I've designed previously. It's just a 3D model that was designed. And in previous webinars, which I know we did drop into the chat, we talk about how can you design things? How can you import designs from Tinkercad? Lots of great resources that I urge you to check out if you are just getting started to the design piece. But this is a very simple little box. I think I'm designing this as like half of a mold where another piece might fit on top. And I want to machine this out of solid aluminum, right? So I know my machine can do that. I know my CNC available can do that. So what I want to do is I want to switch to the manufacture tab right here. And the design doesn't change, but our toolbar does. Our toolbar does. And we see many different processes. So the first tab is for milling. So using like a CNC mill or a CNC router, which is the drill bit type machine that I've been demonstrating thus far. However, you could switch to turning if you were using a CNC lathe. You can switch to additive if you're using a 3D printer. Inspection, if your machine is equipped with it, you could use something like a probing tool to actually measure and do quality control inspections on your parts if you had something available. And under fabrication, you can get into cutting through like laser, water, etc. So I'm going to go back to milling because that's the most appropriate way to make this part. But everything I'm showing you is very similar for any of these processes. You know, the steps that you might do are slightly different for the type of machine, but the actual setup side of it is very much the same. And the first thing that we need to do is we need to make sure that we have our machine in Fusion. So I'm going to open up my machine library. And I have a number of machines, like these are the ones that I own. So I use my Maykara Carvera, and we can see that I have both a 3-axis configuration and 4th-axis configuration, and I imported this machine. So you can add machines to Fusion, but Fusion also has a pretty extensive library of 3D printers, mills, routers, lathes, lasers, a really extensive library that you can browse, and there's a pretty good chance that your machine is already in here. And if it's not, again, you can create your own custom machine. Like if you want to DIY and build your own, you can add and design and create your own custom machine, or you can also import a specific library and profile from another manufacturer that's compatible with Fusion, which is a really, really wide and extensive list. So I have my machine, which is great. I can also open up my tool library. So tools describe the bits, the cutting tools, right? And you might have drill bits if it's a milling process. You might have like blades and things like that if you're using a turning process, right? So again, there's an extensive Fusion 360 library with tons of different bits and things like this for you to pull from. You could even see that, again, there's cutting tools for working with plasma, laser, water jet, all of these different things. You can import libraries. So a lot of vendors that sell tools will give you a library that you can import. So that whole library is importable. And you can also create your own tool. So if you buy your own bits and things like that, and you want to make a tool, it's super easy to click this little plus button, choose what type of tool that you're adding, add the different parameters, and most of those parameters are provided by the manufacturer, so you don't need to become an expert on these things to get started. A lot of it is provided for you, but I will say that one of the most common mistakes that we make when we're first getting started with CNC is choosing the wrong type of tool or setting our speeds wrong. So for example, trying to cut aluminum too slowly or too quickly, I might snap my bit, right? So having those speeds correctly. But if I click on some of these, you'll see that profiles down here. So this bit I can see is available for hardwood or plastic, softwood or epoxy. I personally didn't set that. Those were speeds that were already set by the manufacturer of this tool, which is really cool. And you can also find a lot of great resources on why speeds and feeds should be what they are all over our different guides and tutorials. So I have a bunch of tools, which is excellent. So I have a machine, I have some tools, I have a part. Let's actually manufacture this. The first thing we do is we create a setup. So I click the setup button here, and I need to select my machine, and my default machine was already selected, so I have my 3-axis Carvera, but I could change to another machine if I had different ones here, but I already have my default selected, which is great. This is a milling machine, so I have a milling process selected. And the first thing I might want to do is set my origin. So where would my 0, 0, where's my origin going to be? And this might vary a little bit on from machine to machine, but I think most machines, the origin is in the front left corner. So I click on the front left corner here to set my origin point. This is also where we want to confirm that the axis is correct. So my machine has X go to the right, Y go to the back, and Z go up. But there are other machines that have different axes. And right here in our setup, this is where we can actually rotate. So for example, I might have a machine that uses like a vertical process, and I might actually let's see if I can flip my axes around here, do something funky like that, right? I can actually change where my origin point might be if I designed it one way and my machine is another way. But this is a pretty standard configuration that most, at least mills would use, but you can always adjust things here in the setup. I want to make sure that I have my model selected, so I've selected the body, and it actually does that by default, but you might have multiple parts, so you might only want to select one. And then we want to go to the stock tab. So the stock is what we call the material that we're going to machine from, right? So my solid block of aluminum or wood or whatever, that is my stock. And what Fusion does by default is makes a relative stock. So it just makes stock that's just a little bit bigger than your material so you can see the cutting process. What I like to recommend, especially for folks that are teaching people getting just started, so teaching your students, is actually set the stock, excuse me, to be the size of the material you're actually working with. So I'm going to make this part out of a piece of aluminum, which is 60 millimeters by 60 millimeters by 22 millimeters. Now, interestingly, my part is only 20 millimeters tall. So I can see that I have a little bit of stock on both the top and the bottom, which is pretty common, right? The odds of you finding stock that's perfectly the same thickness of your material varies based on your projects here. So my stock is a little bit thicker than my part, which is more than fine. But I want to actually move my part so it's along the bottom here. So that way I don't have to machine the bottom. I can just machine the top. So I'm actually going to offset my part from the bottom, and I'm going to offset it by 0. So now we can see if I look at this from the front, the bottom is perfectly flush with my stock. I have a little bit of excess stock on the sides. I have a little bit of excess stock on the top, and we're going to machine all of that away to create our model. Now, there's other things you can adjust here. Like, for example, if you want to attach this to a vise or change where the part's fixed, you can get into this, but this is more of an optional feature. You can also adjust your post-processing settings here. We'll talk more about this a little bit later on. The most important thing to know is that nothing is saved until we press OK. So now that I pressed OK, my setup is saved. And I can always go back and change something by double-clicking on it in my browser. Or instead of double-clicking on it, you can also right-click on it and hit Edit. So you can always go back and change things, but you want to make sure you press OK to save your changes every time, right? So we've set up this job. We have our stock, we selected our machine, we know where our origin points are. Now we have to get into actually machining this. And I just want to point out there are so many different processes that you can pick from 2D processes, which is your typical engravings, creating 3D figures and parts and perfect spheres. This would be like making a Nefertiti type thing I showed you versus the J, creating drilling. And I'm going to show you a lot of these, but certainly not all of them. But the nice thing is all of them give you a nice little description about what they do. And there's lots of great Autodesk resources to help you get it. The first thing we need to do is I need to surface or remove the face, right? As we learned, there's a little bit of excess material here at the top, and I have to machine this down to the actual thickness of my model. And this is really good practice because if you buy rough stock, a rough piece of wood, even aluminum that's extruded or something, the top is probably not perfectly smooth. So if you want a perfectly smooth part, you should really machine it to be so. So we're going to use this face feature. So I clicked on face, and now I have a toolpath window, and this is where I set everything. So the first thing I want to do is grab the bit, all right, and different bits can be used. I'm going to go to my tools, and I know that I have a surfacing bit right here. And again, I already have this in my library, but you could browse existing bits and existing tools. And let's say that there's a tool that you use frequently from your Fusion library, which is where I got this from. You can then add tools by just organizing things. So for example, I could, and right now it's showing me that I can only see surfacing tools right now, which is why a bunch of things are being hidden, which is fine. But I can actually grab tools and I can add them to my library, and I can, move tools from one library to the other. I can edit tools and things like that. So you can really customize this to literally be your toolbox and match what you have. And I recommend you put some time into doing that, and you'll adapt it as you go. So here's my surfacing bit. I'm going to select it. And the settings are usually pretty good by default. They might not be the best settings for the fastest machining process. They might not be the best settings for the most detailed and the smoothest, right? You might want to refine things as you get into the concepts of high detail and production, but they're a fantastic starting point. And I have 2 presets for this. So aluminum or wood, although I could also create a custom preset, but I have default feeds and speeds and things like that. In general, the harder the material, the faster your spindle speed's going to be, right? You're going to want to cut at a faster rate, and your movement, your cutting feed would be slower. So the harder the material, your spindle's probably faster and your movement is probably slower. The softer material, you don't have to run your spindle as fast, and you can move a little bit faster, right? So the softer the material, the quicker we can machine it. That makes perfect sense, right? Cutting wood is far easier than cutting aluminum. And again, a lot of these are set as the default. And if I click on these little sidebars, we can see that Fusion actually gives you some calculations because a lot of these speeds are calculated based on your tool diameter. So the diameter of your tool will actually equal how fast it can go as well as how deep you can cut. It's a lot of math, but it's something that you can see and something that Fusion automatically calculates for you, which is really, really great. So we've selected our tool. I'm not going to change any of my default settings right now. I'm going to go to geometry and I need to select where do I want to machine. And we can see that it's actually machining the surface of my block. And this was default, and we will have to select things differently with different tools, but the surfacing, the facing is automatically selected, which is great. So then I go to heights, and this is where it gets a little confusing. I need you to imagine that we have a CNC mill right now. The first height that we want to worry about is the clearance height. So at what height is there no obstruction for our mill to crash? Because that's a mistake. Let's imagine that I clamp my aluminum down. I put clamps on the side to hold it down. I don't want my mill to crash into my clamp, right? That would be bad. So I want to set the height where no clamps will be. And we can see all the way up here, this Z clearance, 37 millimeters above, which is offset from our retract height, is way above our part. There's no way I'm going to have any clamps up there, which is cool. Retract height is where does the bit lift up to before it moves. So again, we want to make sure it's above our clamps. And I'm going to leave this all as the default for now. The feed height is where does it feed from? So that's the top of my material, right? So my feed height right here, okay, we have this light green is offset from the top of my material. So it starts feeding and it starts cutting just before we get into the material. And I want you to think about it for a second. The last thing we want to do is touch our bit to the material and then turn it on. We don't want to do that. If you've ever used the drill press before, we know that we turn on the drill press and then we slowly lower it into the stock. The same would be for your mill. You want it to turn on before it starts to cut, and that's exactly what the feed height is. It starts to turn on 5 millimeters above, and you can adjust all these offsets, but I find that the defaults usually work okay, but we'll adjust some of them later on. The top height would be the top of my material. So that's the top of my material, the top of the block of aluminum, 22 millimeters. And the bottom height is the top of my model, right? So I'm going to machine up to my model. So we have all these blue boxes. It's a little confusing at first, but it's all talking about where the machine goes. And the nice thing is in a moment, we're going to simulate the machine to see how these actually work. So bear with me for one more second because we're going to go to the passes tab. Now we can dive into really, really deep concepts about pass direction, cutting direction. Can you cut in 2 different directions and things like that? Fusion will automatically make the best decisions based on your milling process. And I say the best, I mean, the most likely to be successful, right? Again, it's not going to know all the little details of your machines, so you might have to fine tune things depending on what you're trying to push it to, but it's going to have a really great starting point. One thing that you're going to want to turn on almost all the time is multiple depths. So what that means is instead of trying to surface this in a single pass, right? Let me shave off 2 millimeters in a single pass. Let me do this gradually. And the deeper you're trying to go, 2 millimeters isn't that much, but let's say I want to shave off 15 millimeters. If I try to just plunge my bit 15 millimeters into solid aluminum, I would shatter and crack my bit. So multiple depths allow us to cut things gradually in multiple steps, right? And I can see that I have a default step down. I can also see that Fusion, again, using the length of the bit and the diameter of the bit, it will automatically calculate what the most optimal step down would probably be for your bit based on its length and diameter, which is really cool. And we can see that that reduces it to 3.175 or give or take 0.3175 millimeters or give or take 1/8 of an inch, which is really nice. Some other things, like if you want to flip it over or if you want to do finishing step downs, things like that, you can tweak it. I do want to use even step down, so it'll divide this number evenly across my distance. I like doing that, so I know every pass will be even, so I won't accidentally like do one that's a little bit more than the other. I find that gives me a smoother, more even machining surface. Stock to leave would be if we wanted to make multiple passes with multiple tools. We'll get into that in a little bit. And then linking, I usually don't change these things. This is how it actually connects different paths. I usually like to keep this as the default. I can't say I'm an expert enough to really dive into all the nitty-gritty of all these things, but I do know that Fusion, as you've probably seen, when you hover over everything here, it gives you really nice details. But I find that for most typical simple projects, the defaults are really going to set you right. So I press OK. And what happens is I see a little simulation. So I can see my tool bit, I can see my paths. And what I want to do is hit the Actions tab and then hit Simulate. And I can actually play this and we can see, and I can slow that down. That was very fast. Let me slow this down here. You can actually see your bit plunging into the material, right? And maybe I slowed it down a little bit too much, but it plunges into the material and we can see exactly what it's going to do. We can see all the cuts, all the passes. I can zoom in here and I can confirm that my process is going to be correct. And this is an incredibly important step as you are designing these things, right? We really need to make sure that, you know, we're not cutting in the wrong place, that we're not actually cutting off more material. So simulation is a hugely important step. This will also simulate and tell you roughly how long it's going to take, right? And how far it's going to machine and things like that as well. And that will, of course, vary based on your bits, your speeds, your feeds, and your materials. So I'm going to click Exit Simulation. That looks good. We've machined the surface. And now the next thing I want to do is machine this outer edge, this outer lip. And whenever you choose your tool path, you usually work from least detail to most detail, or from outer to inner, right? So the top, and then what's the outer part and the inner part, working my way down to the finished process. So I'm going to use a 2D contour, which is the path that we're going to use, because when I hover over it, the picture looks like exactly what I want to do. I'm going to go and I'm going to change my tool. I don't want to use a surfacing tool, but I want to switch to maybe like a typical cutting tool, like an end mill is usually what they're called. Again, I'm working with aluminum, and I'm not going to get into changing these settings. I'm going to keep my default settings. But under geometry, what I need to do is select the path. And because this is just a single line, we're going to select what's called a chain. So I'm going to select this chain here. And we can see that I just selected this line. All right. I don't really need to worry about any of these other things right now. There's a couple things that you might want to do. We'll talk about tabs in a little bit. Rest machining is, let's say that you want to do multiple passes. So if I want to use a big bit for like a roughing pass and then a little bit for detailed pass, that's a great feature if your bits don't necessarily fit in your pockets, things like that. Wrapping tool paths is more for like a turning process. And again, I recommend that you spend some time just reading through all these things. Tonight, we're really talking about the standard things you need to know to be successful. So we have our chain. I go to my heights, okay? I have my clearance height, my retract, my feed height, all right, my top height. Now, here's something interesting. The top height was set to the stock top, right? That's the top of my aluminum. But we now know that we just machined the top of the aluminum away. So instead of setting that to the stock top, I'm actually going to set that to the model top, because we just machined the top of the aluminum away. So now I'm basing this off of the model's height, okay? And then the bottom height, where do we want to machine to? I'm actually going to say selection, and I'm going to say I want to machine to this lip. So this is where I'm going to machine to. We'll go to passes. I'm not going to change anything with default settings other than our multiple depths. I definitely want to enable multiple depths, and I'm going to use the default step downs and things like this. Finishing passes are kind of interesting. So a finishing pass will give you a cleaner cut. It does it much slower, and it kind of goes back and forth to give you a nice clean finish. And you can either do finishing passes the whole way, or you can do it only at the final. And the benefit of the final is it saves you a little bit of time. It gives you a nice smooth finish, and it also usually reduces the lines or the marks along the wall. So if you're going deeper like this, I usually recommend that you would finish just at the final. I'm again going to enable even step downs. And then there's a couple things that I really love to do. Feed optimization is one of Fusion's just really fantastic features. Well, it's automatically going to look at your path. It's going to give you the best routes to reduce the load and the stress on your bits, to make your bits stay sharper and live longer. And smoothing is also great. Smoothing, if you have a really weird path or a weird curve, if you imported a mesh or something like this, it simplifies the path to reduce your file size and how long it takes. Awesome features. I'm going to press OK. And this, now we can see we have this pocket. And let's go and let's simulate this. I'm going to speed this up a little bit. So we can see my bit enters, and then it does this outer perimeter, and it machines the pocket of my part. Fantastic. We're doing great. So next thing I want to do is this inner hole, this inner cavity, this inner pocket here, right? So I'm going to use the 2D pocket, right? And again, I talk about your toolbar. So I use the pocket tool a lot, right? If there was another tool I used here, let's say that I use threading, I make threads a lot, I might actually hit this little toolbar button and pin this to my toolbar. And that's how I mentioned you can customize your toolbar so the tools that you want are always there. So let's click pocket. Now this pocket's a little deep, so I'm going to need a much longer bit. So I'm going to go to my tools, and I think I have somewhere in here let's see. I think this is the one I want. I have a nice long bit. I'm looking at my lengths. Here we go. Here's a nice 42 millimeter cutting bit, which is great. That's nice and long, which is exactly what I want. We'll also notice that's a little bit bigger. So it's 6.35 millimeters in diameter. I'm going to switch this to aluminum so I get my feeds and speeds for the metal that I'm working with. I also want to point out that my machine doesn't use liquid coolant. It uses air coolant. The Carvera uses the air, though I don't need it for this project. But some of your machines might use liquid coolant if you're cutting metal, and you can enable all of those things depending on what your machine can and can't do. I typically turn on an air line manually, so I don't need to program that. But there's many, many features, and this is why, again, knowing your machine a little bit before we get to the stage is very helpful. So then I'm going to select my pocket like this, okay? I'm not really worried about any of my other features right now. For my heights, I'm going to set it just like before, where we're working from our model top, not our stock top, because we've already machined the top of the stock off. And I'm going to select the bottom of my pocket. So this is where I'm going to machine to. And then for the passes, same as before, multiple depths using the default settings are more than fine, even step downs. I'm not worried about finishing passes for this. It's not important for this product, but I do want to enable not stock to leave. I want to machine all the way to the bottom. I'm not really worried about leaving a buffer stock. We'll talk about that in a moment. But I do want to enable smoothing and feed optimization. So I press OK. And this is the most complicated one that we've done. So we have our pocket. Now, this looks potentially correct. Okay, right? And I can simulate this, and this looks, I think, fine. But we have a minor issue here. Look at this simulation. I'll let it finish. Notice here, it's hard to see maybe, this is the corner diameter I wanted in my design, but this is the diameter that Fusion gave me, right? Why is that? And it's because this 6.35 millimeter bit doesn't fit into my corner, right? It'll machine the pocket, but I need to look at my design and say, you know what? That's not going to where I need it to go. So you have a couple options here. I could machine this first with this big bit, which will clear out material very quickly. And then I could make a second pocket or a contour to then just do the outer perimeter to clear away the excess material. Or I could just switch to a smaller bit, right? It depends on what you have available. If you only have smaller bits, that's probably your best option. If you want to do multiple paths, I could actually create a contour. Let's select that nice long bit that we used or talked about before, right? But this one's only 3.175, so it's a much smaller bit, okay? I'm going to say aluminum. I'm going to select just the outer perimeter, not the pocket. The pocket's already been cleared from my bigger bit, okay? I'm going to just change my heights to be exactly what they were before. So our model top and our bottom of our pocket. And again, I'm going to enable multiple depths. And you can see this is getting rather repetitive. And again, I find these settings that work for me, and then I just use them for almost every job. And then I might have to do fine detail and things like that for different precision and things. But in general, I find that these are just really good practices. So let's see, when I go to machine this, we can now see that my corner, it's still not perfect, right? This bit still might be a little big. I might have to use a slightly smaller bit, but we can see how much closer we are, right? This is much closer than I was before. Really, I might need to use like a 2 millimeter bit. And the cool thing is I can just go back into this toolpath. I can change my bit. Let's see if I have a smaller bit somewhere around here in my library. Let's see. This is a 1 millimeter bit. Here we go, 2.5 millimeter bit. That's a little bit smaller. All right, I don't have aluminum set up for this, but that's okay. For now, I'll just leave it. I'm going to manually punch in our numbers because I don't have a profile. So we mentioned that you can punch in the numbers. So I'm just going to manually punch in all my feeds and speeds that I was using for my other bits, and I press OK. And if I simulate this one, let's see if we can get a little bit closer to our corners. Yeah, there we go. We're pretty much spot on, right? So you might have to, again, play with this and find your different bits and get this to line up. Now, here's something interesting. You'll notice next to my bits, it says T, tool 6, whatever it might be. Okay, so this is the assignment of my tool, right? Now, I have two different tools here. I have my 6.35 mil and I have my 2.5 mil. But they're both assigned to tool slot 6, and that would be bad because what has to happen is we need to change between the tools when we're machining. And if depending on the type of mill you have, the machine might pause and ask you to load a different bit, right? So it might sit there and say, okay, insert tool 3, insert tool 4, and you would have to kind of know which tools those are. Or you might have a machine that has an automatic tool changer, right? And I'm just going to switch back to the PowerPoint real quick because I have a nice little graphic. So you can see this machine, and somebody asked earlier, this is called the Carvera Makeera. It's a really capable machine that can do a lot of things. One of my favorites for schools specifically. Can actually switch between the bits. So if I assign this tool 6, it would actually go over here to the tool changer and pick up tool 6 for me. And there's a lot of machines that can do tool changing. Most of them are at a higher price point. This one in particular is a really affordable machine. But nonetheless, we can actually program those tool changes in Fusion. So right here, I have two different tools, but they're both assigned tool 6. What do? Well, I want to actually go into my tool library and I want to renumber this tool, and I can see I'm using 3, 4, and 6. So let's reassign this to tool number 1. Okay, so if I go and I reassign this and now press OK, we can see that I have tool 1 for this. So my machine would actually grab a different tool, or even if you didn't have a tool changer, it would pause, it would wait, whatever it is. So we're almost out of time, but we have 2 more paths, and I think we're going to be able to make it. We're going to do a drilling function. Okay, so I'm going to say drill. I'm going to select a drill bit, which I think was automatically selected, which is super convenient. But I'm going to select a drill bit here. So this is a 1.5 millimeter drill bit. I have aluminum set up, which is great. And you can see I have 4 holes. So I'm going to select my hole faces. And if I hover over them, you can see that I have these little paths like this. All right, which is great. I'm going to adjust my heights. And interestingly, what I'm going to do is my top height is going to be the hole top. All right. The bottom is going to be the whole bottom, but you have some options here. Do you want the drill tip to emerge through the bottom, right? Do you want to plunge all the way through? Do you want to offset a little bit deeper? Let's say you're trying to cut through material. The material might be a little warped. Do you want to plunge all the way through the material? You can adjust those. What you really need to think about is the drilling cycle. Okay, so the default is rapid, which means it's kind of like a drill press and you just go straight down really fast. That's a very quick way to snap your drill bits, especially if you're working with a harder material like metal. So what you probably want to do is what's called chip breaking or deep drilling. And what this does is pecking or retracting. So after it drills, it's actually going to lift out of the hole, let the chips evacuate, keep my bit nice and sharp, and drill it gradually. And that's something that you definitely want to enable. If you want, you can even put a pause, which is called dwelling. So it kind of waits a minute before it goes back in, gives you a chance to cool the bit down. Aluminum's not that big of a deal, but if I was doing titanium or steel or harder metal, I would definitely want to consider that, doing this as slow as possible to keep my bits sharp. And then if I go to simulate this, we'll see, and let me slow that down. We'll see, okay, not that slow. Let me find a happy medium here. That my drill bit drills and it pecks, right? It's drilling it gradually as we go to keep our bit nice and sharp to evacuate the chips. Okay, and now I can see I have a conflict here. My drill bit's assigned to tool 4, but I already have a bit assigned to tool 4. Can't have that, right? That would cause a conflict and an issue. So I'm going to renumber this. Let's move this to tool 2. All right, so that's nice and cool. And then the last thing we need is we got to cut this part out, right? We have our part machined, but I need to cut it. And that's actually going to be a contour cut, which we used earlier. So for this, I'm going to use the same really long 3.175 drill bit that I used earlier. So I can actually go into the bits that I've already used, right? So I can see that I've already used this one. It's already assigned to tool 4. I already have my settings. I'm going to select the bottom edge of my part like this. And now this is where tabs come into play. So when this part's cut, what's holding it in place? Nothing. And it could evacuate and fly out of your machine. And if your machine's not enclosed, that could be a huge hazard. It could cause damage to your machine. So tabs add little tabs that can be cut off. And Fusion will automatically draw them. You can set by the number of tabs you want, by the distance of tabs you want. You can also draw them manually. So I might say 0 tabs, and then I might manually put a tab here, 1 here, and 1 here. You can adjust the size of the tabs if you'd like. You can make them bigger, thicker, wider, whatever it might be, smaller. And again, you would cut those with a handsaw or something after it was done. I'm going to set my offsets to be exactly the same. Model top. This one's going to be model bottom. If I wanted to cut all the way through, I could, right? So I could plunge all the way through. And sometimes I even actually like to say selection and just say this and set the selection like that. So I know exactly where it's going to end. We're going to add our multiple depths, especially this is going to be a lot of cutting. So I'm going to cut this nice and gradually. I'm going to enable even step downs and finishing only at final to save some time. And I'm going to enable smoothing and feed optimization like we did before. And when we press OK, we see our most complicated toolpath to date, but we also see this cut all the way through. And what I'm going to do now is I'm going to click away and I'm going to hit simulate with nothing selected. And I'm going to speed this up here. But this will simulate the entire process, the surfacing, the pockets. Okay, I can go a little bit slower. This will machine it. We can see the surfacing, the pocket cutting, the milling, right? Then the drilling, and I can inspect this whole process here before I send this to my machine. And now you might be thinking, okay, how do we get it to the machine? Well, that is called post-processing. So right here, we have this post-process button, and this is what generates a G-code file that we send to your machine. So let me pull this window. It just popped up on my other screen. Here we go. All right. It's super important that you process it using your machine. So I'm using my Carvera profile. I can name this, so I can call this like mold part. All right. Whatever your machine runs in, most machines would run in millimeters, even if you design in inches. I want to make sure I export in that unit. If I want to split this into multiple files, let's say, for example, I want to do the first 3 toolpaths and then flip, I can split this into multiple files rather than one. And then I also want to enable whatever pockets or processes or operations I want to do. So I want to do everything. But let's say I'm going back and I just want to drill my holes a little bit bigger. I might disable everything but drilling and just send just that, right? So you don't have to send them all, but you can. And when I hit post, a little G-code file is saved, and I can then upload that to my machine and however your machine works, right? So listen, we just covered a ton of stuff super quickly. And I just want to remind you that this is recorded. So you can go back, you can review, you can revisit things like this. And really, I just want to talk on the process. This is a very repetitive process. And what you want to do is start with your design file, make sure that you're understanding what your machine can do, bring it into the CAM program, create operations, simulate and adjust. If something's not right, tweak your settings, right? Then adjust it, do it again, simulate it, inspect it many, many times to make sure it looks correct before you then create your G-code file and then send it to your machine to actually manufacture. And listen, I'm cutting this one a little close, so I'm going to go through the last little bit a little quickly here. Again, reminding you that CNC is a super diverse area, and Fusion offers the tools and the capabilities to allow you to do just about anything from subtractive, additive, even talking about formative, whether you're using a turning process, a cutting process, really a ton of different resources in Fusion. If you want to step up your Fusion skills or also allow your students to build their resumes, there are official Fusion 360 certifications. There's ones also specifically for CNC and CAM and manufacturing provided by Autodesk, which is a great real-world learning experience. I also want to thank you all for being here live because we're going to send out a professional development certification for your 1 hour of PD, along with the slides and the recording. We'll send that to you in the next 24 hours or so. And listen, right before we sign off, Randy, can I put you on the spot for a high speed tell us about Instructables?
Yeah, so Instructables is a project sharing website. I'm going really fast now. We have a page specifically for Fusion, and so if you want projects, we have CNC projects, all kinds of projects. Go to instructables.com/teach, click the little Fusion button, and find all kinds of cool projects there. And we currently have a contest. It's closing soon, but if you have something and it's like ready to go, February 5th, we have Anything Goes contest. You can submit anything. It's a good way to kind of get your feet wet. We have an arcade contest currently running, which is specifically for Fusion projects, and it's a student design challenge, and anything related to like arcade gaming, like a skee-ball machine. It's not like designing arcade games, it's like building cabinets and controllers and consoles. So that should be a fun one. And then we have the Make It Resilient contest, which basically any Autodesk project. This is for students, high school, junior high and high school, and who are interested in architecture, and they can kind of make something for the future for extreme environments.
Super cool. And I also know that we have a lot of different contests coming out soon. So stay tuned. We'll talk more about it in our next webinar series. And to remind you, the next webinar series is going to be in a different place. So you need to register with a different link if you haven't already registered for the Teaching with Tinkercad series. Same time, right? So same time, 7 p.m. Eastern time or 4 p.m. Pacific time. But we're going to be meeting on February 15th to talk about creating electronic circuits and things in Tinkercad. So that link is in the chat, that link is in the blog, and that link will be in our slideshows that we share out. And we really hope to see you in 2 weeks' time. Now, listen, before we dive into our Q&A, and we don't have a ton of time, but we do want to stick around and answer any questions you have, although I've noticed the Q&A has been a little quiet tonight, so hopefully we're just soaking it in and we're learning. I want to say, again, thank you all so much for being here live with us tonight. And of course, please check out the recording, the notes and things like that if you want to go back. And a huge thank you to the Autodesk team that's been with me behind the scenes, right? So obviously you've heard from Randy and I, but we have Nicole, we have Jonathan, right? These folks are here to not only help support us as we're running these webinars, answering your questions, but making the Autodesk products the way that they are and how awesome the resources are every day. So huge thank you from us at the Autodesk team. Thank you for joining us for this webinar. If you're signing out, we hope you have a great night, and we hope that you enjoyed.